Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about how do speakers work. Today we're going to be talking about, well, how do speakers work? So as you know, maybe you're just singing some song or just giving some speech, right? And while you're doing that, you connect it to your microphone, or maybe you're just chilling in your room and you turn on a speaker, right? And it starts playing some music or sounds. But how does it actually work? Like, what are the insides? Well, in this mess over here, this is what inside of a speaker would look like, okay? And there are mainly two parts of the speaker: the motor and the cone and suspension. Let's look at the motor first. The motor is made up of a few components. The first one being a voice coil, okay? The voice coil is made up of two pieces, okay? The first piece is a heat-resistant coil, okay? And the second one is a copper wire that is stranded around it. So the heat-resistant coil, also known as a former, is connected to the copper wire, okay, which is fitted in between a large permanent magnet, okay? And because of this, this all creates a magnetic field, okay? And due to this magnetic field, we create an electromagnet. Now, some of the benefits of an electromagnet include it acts like a permanent magnet, okay? And we can control the polarity and the the magnetic intensity, because by just changing it by how much electricity we can input it in, okay? So this all basically ties into, so the coil, okay, the voice coil is fed a specific type of electric waves, okay, a specific type of current, which is actually a perfect replica of that audio that we want to play, okay? So it goes inside here, and the electromagnet basically forces the voice coil to move back and forward at a bunch of times, okay, at the specific rates needed, okay? And that's basically all that there is to the motor, okay? Now, as for the cone and suspension, what the cone does is basically it turns those movements of back and forth into sound waves, okay? And there are many other parts. For example, there's a dust cap to keep all dust and debris away from the main inside components. And the suspension system, okay, what that does is there are mainly a few parts of it, being the outside area, okay, the surrounding, okay, it's called the surround, and the inside area, okay, being the spider, okay, which holds it together, okay. And if you remove the dust cap, there will be this another thing called a tensile, okay, which connects to the copper wires from the voice coil, okay, which basically diffuses how fast it goes. So if it continuously moves faster, faster, faster like this, it diffuses it a bit, okay, muffles it. But how does this moving back and forth actually turn into sound? Well, you see air, okay, like air molecules, okay? You could think of them as like just this flat space, okay? And if we control like the pressure in it, it basically creates like this pressure, this force. If we put a force through it, creates this force. That's what the speaker is doing right now. By moving back and forth, it's creating a bunch of, it's basically creating a disturbance within those air molecules. And let's say in our ears, okay, our eardrums are specifically designed so that way when those disturbances of air molecules hit the ear, that's basically what a sound wave is, okay? This is what it is in reality. In graphically, a sound wave mostly looks like this on charts, but in reality, it's that, okay? So that's basically how a speaker works. That's basically it. Thank you for watching this video and hope to see you next time.